See these two questions. If capital A is a square matrix of order n, then prove that adjoint of adjoint A and take a determinant, the determinant of this matrix, adjoint of A equal to det A power n minus 1 whole square. So try to understand that expression, adjoint of A. So what does it mean? We have a matrix A, we have to find out the adjoint of the matrix by finding the cofactors and taking the transpose. And after you get this, again you have to do the same. So two times you have to find out the cofactors. See, there is one matrix, find out its cofactors, take the transpose, and for the resulting matrix also find out the cofactors and take its transpose. Okay, so once that is done, right, so once that is done, they wanted us to show that the value of that final resulting determinant of the matrix is original matrix determinant raised to the power of n minus 1 square. Okay, so how to solve it is, let us assume that adjoint of A is a new matrix called B. Now in place of adjoint of A, I am going to substitute B. I'll take LHS, which is adjoint of A, right? And now in place of adjoint of A, I am going to substitute B. Then what do I get? Adjoint of B, right? And we know that since A is a n by n matrix, adjoint of A is also n by n matrix, therefore adjoint of B is n by n matrix. And earlier I just have shown you a proof that determinant of adjoint of B will be equal to determinant of B raised to the power n minus 1, right, where n is nothing but the order of the matrix B, that equal to adjoint of A. Now I am substituting in place of B adjoint of A raised to the power n minus 1. Okay, and we know that already we know that adjoint of A is nothing but determinant of A raised to the power n minus 1, right, and already there is n minus 1 here. So how did I get this? Because the order of A is n by n, that is what is given. A is a square matrix of order n, so we got this n minus 1 whole square. See, simple, steps are simple. I have taken the LHS and I assume that adjoint of A is a new matrix B. Then in place of adjoint of A, I have substituted B. Then what did I get? Determinant of adjoint of B. Then determinant of adjoint of B is nothing but determinant of B raised to the power n minus 1, right? And then in place of B again I substituted adjoint of A, because that is what we assume. B is nothing but adjoint of A. So adjoint of A I placed it, right? And then adjoint of A, determinant of adjoint of A is nothing but det A raised to the power n minus 1. So it is this. Got it? So that is the proof of the first question. Now let's see the second question. Now in the second question they are asking us to show that if A is a non-singular matrix, they are asking us to show that adjoint of A equal to, okay, I'll do here. Now let's see this, the second one. If capital A is a non-singular matrix, then we are supposed to prove that adjoint of A equal to det A power n minus 1 into A. See, earlier question is about finding the determinant of this matrix. Now this question is about finding the matrix itself, which means if you have to find out the adjoint of the matrix two times, see, what is importance of this question is adjoint of A, this is what is given. So the meaning of this question is, first we have to find out in order to find out the adjoint of A, we have to find out all the cofactors of the elements A and then transpose it, then get the resulting matrix and again find out the cofactors of all the elements of the resulting matrix and again transpose it. Is going to be very big, right? But if you can somehow prove that taking 2 times adjoint of A is nothing but finding out the determinant of A raised to the power n minus 1 into a, then we can just find out determinant of a and take the a and multiply with that this number, this constant, that a power n minus 2. It is simple, right? That is why this proof is important. Now let's see how to prove this. We already know that a into adjoint of a is equal to det a into I, right? Now what we shall do is, in place of a, let's substitute adj. In place of a, I am going to substitute adjoint of a. So here I get adjoint of a, and here I get adjoint of a, right, equal to det of adjoint of a into I, right? Now we know that determinant of adjoint of a is already det a power n minus 1, that we already know it. So adjoint of a into adjoint of a equal to det a power n minus 1 into I. We already know this. Now let's multiply both sides with a. That implies a into, I am multiplying both sides with a into adjoint of a into adjoint of a equal to, here also I am multiplying with a into det a power n minus 1 into I, right? Now we know that a into adjoint of a is nothing but det a into in into adjoint of a equal to, here det a power n minus 1 into a multiplied with I is nothing but a, right? So now we can divide both sides with det a. So how is it possible? Since it is non-singular, which means det a is not equal to 0, we can both sides divide with det a. So if I divide both sides with det a, and we know this, here anything multiplied with identity matrix is same. So here I get adjoint a adjoint a equal to det a power n minus 2 into a, right? See, sometimes I am writing in and sometimes I am writing I. Don't get confused. Whatever it is always an identity matrix, and the size of it depends on size of the other matrices. Okay, so now we have got that adjoint of a. And if we want to find out this matrix, we need not actually keep on finding out so many cofactors. You can directly find out the determinant of the matrix A and then raise it to the power n minus 2 and multiply that constant with the original matrix A. So it is a shortcut. Okay.
Hi, if you are planning to do masters, then doing masters abroad is better than doing masters in India. I'll give you all the reasons. So, first reason is, out of 1 lakh students who take GATE every year, there are only 500 seats in old IITs. So all the IITs put together have an acceptance rate of 0.5%, and IITs, universities better than IITs, they have very good acceptance rate like 30%, 40%, but all the IITs put together have an acceptance rate of 0.5%. And if you are working hard to get into IIT Bombay's ranking is 177 and IIT Roorkee's ranking is 400. If you are happy to get into IIT Roorkee, then getting into universities better than IIT Roorkee is easier compared to getting into IIT Roorkee. And looking at the salaries for computer science, for software jobs, if you have done your masters in computer science in US, the salaries are ranging from 80 lakhs per year to 1.2 crore per year. So even if you take an average of 1 crore per year, your savings will be much higher than the salaries in India. After taxes and your cost of living, you can easily save 40 to 50 lakhs per year. And in India, the maximum jobs that you get is around 30 lakhs. So your savings will be much greater than the salaries in India. And these are all the services that we provide. University shortlisting. So depending on your profile, we will shortlist what are the universities that you have to apply, and statement of purpose building, and then LOR guidance, and GRE and English test assistance, and education loan assistance. So you don't have to have any collateral, which means without any security, now you can get education loan. Getting education loan is very simple these days, and whatever the amount of fee that you have a range of universities. You can apply for 10 lakh universities, 20 lakh universities, or 50 lakh universities. But whatever it is, you are going to get complete education loan, and you can pay off your education loan in 1 year after you get a job. And then we do visa assistance, mock visa interviews, and then connecting with the university alumni. So now you might ask why we should join Game of Visas. So the answer is we have 90% success rate, 99% success rate. And these are all the destinations that we guide the students to. So we guide students to any country that you want to go. So now it is not just USA. We guide to UK, Germany, Australia, Canada. So we guide students to all the countries. We work with all the destinations. And if you are interested in going abroad, you have to just drop us a message on this WhatsApp number 9494 555 454. Okay, thank you.